Good day and welcome to class. We have a very interesting Diophantine equation on the board to solve, and we shall be solving this equation together. I am going to be solving the equation in two ways, but I will be treating the first way in today's lesson. In the subsequent lesson, I will be using the other method. So just stay tuned and watch out how we are going to solve this equation using two methods. The first method is the general method, which I'll be doing in this class. If you are yet to subscribe to this channel, kindly click on the subscribe button, as well as click on the notification bell so that you can get the alert as we drop videos on this channel. And do well to share this video with your friends and loved ones. So let's go right into the solution. Here we have that 2x, 2 to the power of x, plus x to the power of 2 equal to 8. We have to find the value of x. You can see in this place, x is a power. At the same time, here, x is a base. Good. So, to solve this equation, see what the steps I'm going to take. The first step I will take is to move this x squared to this right hand side of the equation. So, the equation will become 2 to the power of x equal to 8 minus x to the power of 2. Then, looking at this equation here, I want to do it in such a way that it will look like difference of 2 squared. So this becomes 2 to the power of x, which will become 8 to the power of 2 divided by 2. You know, 2 divided by 2 still gives us 1, right? Good. So minus x to the power of 2. Now, knowing that from the rule of indices, if I have a to the power of m, n, it is the same thing as a to the power of m times n, or a to the power of n times m. They are the same. So I want to play on that rule here. I can write this like this: 8 to the power of half, because 1 over 2 is that half, all multiplied by 2, so that if I can multiply this back with this, or cancel to give me back my 8. Good. Minus x to the power of 2. So now this looks like difference of 2 squared, where we have x squared minus y squared, which becomes x plus y and x minus y. So I will be using that to solve this particular stage. I will have this to be 2 to the power of x. So this will become 8 to the power of half plus x, and 8 to the power of half minus x. Good. Hope you are following. Now, I cannot apply the product rule here like this unless I create another term here. I need to create another term here for this equation to qualify to use the product rule. So I would call this 2 to the power of x multiplied by 2 to the power of 0. 2 to the power of 0 is same as 1, so that my equation here will still remain 2 to the power of x at the left hand side. Then here I will have 8 to the power of half plus x. Here 8 to the power of half minus x. So at this point, I will equate this to this and equate this other equation to this. That's what I want to do now. Now, equating it as I've said, 2 to the power of x becomes equal to 8 to the power of half plus x here. That's my equation 1. And 2 to the power of 0 is equated to this, like I have it here. So at this stage now, we add equation 1 to equation 2. So I'm going to add these two equations together. So adding it together, here is what I'm going to have. Adding equation 1 to 2, I will add this to this, that's what I have here. Then this plus this is what I have here. Then plus x minus x is like saying x minus x, which is 0. So this part now will look like this: 2 to the power of x, 2 to the power of 0 is 1. Then 8 to the power of half appears twice, so this becomes 2 times 8 to the power of half. And anything to the power of half means what? Square root of that particular thing. So this is 2 to the power of x plus 1 equals to 2. Let's find out the square root of 8. So if I do 2 times 2.828, for what am I going to obtain? So multiplying around 5.6568. So I'm going to push this one to this part. So this becomes 2 to the power of x will now be equal to 4.6568. Good. So it looks like what we are familiar with. 2 to the power of x equals to this. So in order to obtain our x now, I have to take the natural log of both sides. So I will be saying ln 2 to the power of x equals to ln 4.6568. And to resolve this x is going to multiply the natural log here. Then we now divide both sides by ln of 2 to get our x. This x is multiplying this equal to this. That's what I have here. So in order to obtain my x, I'm going to divide both sides by ln 2. ln 2 here cancels out ln 2. So my x, what is ln 4.6568? That's 1.5383. Then what is ln 2? 0.6931. And if I divide this by this, what will I get? I'm going to obtain 2.2194. So that gives me an approximate value of 2. And let's check if we are correct. If x is 2, this is 2 to the power of 2, then this is 2. 2 to the power of 2 is 4, then 2 to the power of 2 is 4. 4 plus 4 gives us 8, which means the value for x is correct. Hope with all we have been doing, you are able to catch the steps, and I expect you to be able to replicate same, as I'll be dropping an assignment with you shortly. So attempt this question, right? And drop your solution in the comment section. And to just help you to know if your result is correct, the correct value for x is 1.13. This brings us to the end of today's class. And I did promise you from the beginning of this class that we'll be using 2 methods. So watch out for the second method, which will be the use of the Newton method in solving the same problem. Bye for now.